Greetings to all, dear friends. This is DMS Company with you. In the previous episode, you saw a review of this Dodge Ram 1500 model year 25 in the Bighorn trim. This vehicle will be delivered to our client in the signature style and BMS engineered. We will develop front and rear power bumpers, power side steps, skid plate protection, and additional lighting for it. In this episode, we will show you the process of designing, modeling, and manufacturing. So, subscribe to the channel, like, and leave comments. Now let's discuss what structural differences this vehicle has compared to the previous 24th model year.
Of course, the main difference for us in the 25th year was that, unfortunately, Chrysler moved away from the legendary V8, the one we all love so much. 5.7, we idolized and believed in it. Now it's the era of new technologies and replacing the legendary V8 5.7, and in some cases 6.2 with a supercharger, is an inline 3-liter twin-turbo engine. This is what awaits all manufacturers now, and in principle, there are probably almost no manufacturers left in the 25th year who have retained larger engines. Well, due to the fact that the engine changed, the entire external infrastructure also changed. Accordingly, the main difference is that the engine is installed differently and it has a different transmission. This led to a change in the frame. The frame changed to a small extent. It's not to say that it happened in a fundamental way. There were small technical changes, but they will directly affect the production of new power tuning elements. One of the most significant and visible differences that we can observe on this vehicle is that the Ram has an active radar for active cruise control, which is located in the middle of the bumper. On the 24th model, it was located somewhere behind the grille, and it didn't interfere with our work on this car. Now it is positioned in the center of the bumper, typically where a winch and the license plate are installed. We'll have to do something about this, relocate it somewhere, and figure out a way to integrate it so that it looks factory standard while retaining all its functional features.
Are there other differences?
Yes, of course, there are these differences. They are not very significant, but very important. First of all, the parking sensors have changed. They now have a different design, which means a different mounting will be needed for them. And another main difference is we can't see it now. Behind the bumper there's a large additional cooling radiator.
Enclosed?
Yes, and in the bumper itself there are shutters. And this is the biggest problem we will have to deal with. Because when installing just the bumper, yes, of course, we can add additional vents, make and maintain all the necessary airflow. But for those who wish to install a winch, this will be a real problem that we will have to tackle. Perhaps we will make some air ducts. Maybe it will be necessary to relocate this radiator. I don't know. As we proceed with modeling and production, we will understand what exactly needs to be done. To get started, we will now disassemble the car and scan it completely. We will have a complete 3D model of the car itself and all its elements: the bumper, wheel arches, parking sensors, LiDAR sensor, and all necessary additional radiators. And based on this, we will be able to design a completely new product that will fit well into the design of this car because, of course, it's very easy to ruin this charismatic appearance, and we really don't want to do that. Because the main goal of VMS engineering is to preserve the authentic appearance. That is, whenever I design products, an important task for me is that, for example, when people see the finished car, they wonder, oh, did the manufacturer release some special off-road version rather than just, let's say, as is common in certain circles, making a bumper out of a piece of metal just for protection. So, reliability, protection, practicality, these are default priorities for me and our entire team, but the appearance is of utmost importance. And for this, we take design and the preservation of all standard structural elements very seriously.
And what about the frame itself and the rear part of the car?
Well, it's still not entirely clear, actually, what's going on with the frame. Externally, it looks very similar. Certain differences are obvious. To specifically understand how it differs and what its features are, we will now fully scan the frame in its standard state. We have the frame of the 24th model, and we also have scans of the Tri-X frame. We will overlay them and clearly understand where changes have been made. I am sure that the central traverse has changed, the mounting points for the gearbox and cushions have changed because, well, the engine is different, the weight distribution is different, plus the transmission has changed. Accordingly, we will see all this on the scan during the process of designing the skid plate in the rear part. There were also quite significant changes because for some strange reason, in the 24th model, the rear brake lights were LED and the blind spot monitoring was integrated into the rear brake lights. And now they have installed bulbs and the blind spot monitoring has been relocated. We couldn't figure out for a long time until we got the car in our hands where exactly they had moved it. There was an understanding that it was probably somewhere in the bumper, but it wasn't entirely clear where exactly. While working with this car, we found the location. That is, the rear bumper increased in size. And in relation to the structural part, the metal part itself, they made a large plastic section where they placed the parking sensors and installed the blind spot monitoring. And this will greatly complicate our work now because we can't just take it out and move it. And since the structural bumper is made of metal and the blind spot monitoring reacts to metal, we can't place it behind the bumper. Therefore, we need to create some openings or integrate it somewhere so that it looks good. Perhaps we will do it like we solved a similar problem on the Silverado, that is, we made additional openings in the bumper, placed the blind spot monitoring sensor there, and on top, we 3D print plastic covers with a nice label indicating what it is. And this way, we will most likely solve this problem. Just off the top of my head, I'll give a little spoiler. We considered the rear bumper from the 24th model. It matches the main control points, but the central mounting has changed. So, apparently, the tow hitch on this car and on the 24th model are different. That is, the bracket where we attach the central two bolts of the bumper to the tow hitch does not match here. So, there are holes there, but the bolts themselves are located in a different place. Well, that's not a big problem either. Now we'll scan the rear part and design a new bumper because all these issues seem minor. In essence, if desired, you could take a bumper from the old frame and put it here. But that's not our method. Why modify something? I repeat, we strive to create solutions at the level of an automotive manufacturer. Accordingly, everything should be completely bolt-on, fit in their places, and maintain the full functionality of the vehicle. Because the goal is to make the vehicle better, not just change its appearance.
So, in the previous review, we saw that the mounting of the thresholds here is a little different as well. How does it differ structurally? Could you please explain in detail what nuances we will encounter, specifically when developing the thresholds?
Yeah, we noticed that. Right away too, that there are differences, but that's a feature. At first glance, we thought it was between the 24th and 25th year. No, it's exclusively a configuration component. That is, the Big Horn is considered practically the lowest trim level among full-size Dodge Ram pickups. And here, it's a kind of, let's say, budget version. In more advanced versions like the Rebel or Limited, they already have the same brackets with 3 arms Here, there are 2 of them. But this is apparently just for cost-saving purposes. Therefore, there is a strong belief that the thresholds of the 24th model and the 25th model will be the same. We, of course, scan the frame, the body and the frame. We will definitely check all of this, but at first glance, visually, what I saw, I think it will be the same.
Okay, cool. And what about additional lighting? Will there be some kind of bar? Or lighting solutions?
No, here. The additional lighting will be installed on the hood. Right now, it's the most trendy thing. That is, people have really taken to installing lights. On the hood, 2 LED headlights are installed. They are mounted with special brackets for hood bracket mounting, requiring no modifications and are very convenient. So, this kind of lighting is positioned quite high and provides good illumination. But at the same time, when you're driving off-road and in the shade, in the dark, it doesn't glare on the hood. The problem is that when you install lights on the roof, especially near the windshield, when you turn them on, your windshield and it get very brightly lit. Yes, you can see far, everything seems great, but the front part itself isn't very good. Your eyes get a bit tired from this, especially if you're driving for a long time. But this kind of light, which is mounted on the edges of the hood, illuminates well enough without glaring on the hood itself, and you can cover long distances without turning it off, even in the dark.
So how does the process of designing and manufacturing happen?
That's a good question. Basically, the same stages always occur. The most important and primary first stage is that to start designing a new product, you need to do a 3D scan of the car. The car is disassembled. All its reference points are scanned, and all elements that will be installed on the car, such as parking sensors, towing hooks, LiDAR, and so on, are scanned. In other words, everything necessary is scanned. From this, we essentially get a 3D model of the car. The first stage is rendering. First, a render of the new car design is created in one program. This is, in principle, about 90% close to the real picture. So first, we model the design itself. It already looks like what the production model will practically look like, but it's still just a picture.
So, after we completed the 3D scanning process and prepared the car design, we then move directly to production. And what does any production start with? It starts with the design and engineering department. Next, we will show you how the design process of these elements takes place. Let's go. Here we have a finished 3D model that we measured from the scan. So, we've created the design, we're designing, and now we're working on the development of the interior, specifically the mounting and the platform for the winch. We have a 3D model of everything, the car itself, and the components that will be installed. We fit and adjust everything to ensure it fits precisely and in the right place. We are also currently working on the skid plate, which we are designing in the same way using the 3D model. We have a complete scan of the vehicle, both the exterior and the internal parts of the frame. Right now, we are adjusting the skid plate to all the control points to ensure it reliably protects the vehicle in tough conditions. Here we have a 3D printer, which we use to print complex items like bumper covers, blind spot monitoring caps, and various other decorative pieces. So we don't have to make them out of metal, but instead create them more qualitatively, beautifully, and integrate them into the vehicle's design. These are the kinds of things we make. All of this happens right here. Now let's move on to the production process. After the design is ready, the modeling is complete, and all the technical documentation is prepared, the actual production begins with laser cutting. Sheet metal is placed into a special machine. And this is how shaped elements are made from it. This machine can cut any metals, aluminum, mild steel, stainless steel, with very high precision. The products from this machine come out perfectly even, with high precision, and if everything is designed correctly, they require no fitting during further assembly. After the metal cutting is completed on the machine, the cut pieces are organized into separate productions for each individual product. Then it moves on to the metal bending section. An intermediate step between cutting and bending for some products is the process of dimpling. This is when metal is given a 3D shape through special forms to increase rigidity. After we have completed the dimpling process, one of the most important stages of the production process is the bending process, where a specialist uses CNC machine tools to shape the metal from a flat sheet into various geometric forms according to special drawings. This is how it happens. We also have a section for turning and milling operations in our production. Everything is according to its production processes and technical documentation. It waits until it goes to assembly. After the metal is cut and bent, the next stage is the actual assembly. Throughout the production process, at each stage, the specialist has the necessary technical documentation and all the required measurements for assembling the products, ensuring high precision and quality. Each part fits into its place, and according to the necessary dimensions, everything is double-checked. Initially, the product looks like this. Everything is precise, even, and in its place. And after that, the welding process of this product takes place. One of the most important stages of the production process is the final preparation and painting of the products, because it doesn't matter how you welded, cut, and assembled the product. If it is poorly prepared and painted, you still won't be satisfied. In this area, we are precisely engaged in the final preparation. First, the products are constructed, then all the seams are processed, and the surface is leveled to a perfect state. After that, all defects are checked, and then it goes to the painting line. After we apply the primer and paint, the item is moved to the polymerization oven, where it stays, and at a temperature of 220 degrees, the coating crystallizes and becomes reliable and durable. So well, friends, we have just gone through the full cycle of the production process, the final touch of which is the packaging of the finished product. You just saw how the coating is applied. Now we are taking these products out of the booth, still hot. Ouch! In just a few minutes, they will cool down and we will begin the packaging process. Friends, today we went over how the process of off-road tuning production looks. Now everything is ready, packed, and heading directly for installation in our showroom. In the next episode, you will see the final look of our Dodge Ram in the BMS configuration and the car owner's reaction to what he received. To stay updated, stick with us and subscribe to the channel if you haven't done so yet.